The National Weather Service in Shreveport has issued a tornado warning effective until 3 p.m. Central
Few would disagree that there remains a great deal yet to be learned about climate in general, and atmospheric circulation in particular. Yet meteorologists are making great strides in their efforts to increase the accuracy and utility of their forecasts.
There are many advances in weather forecasting. The National Weather Service in the United States has been significantly modernized in the last 12 years, and the effects have been, I think, dramatic. For example, the new Doppler radars that you see sometimes on TV all over the United States have improved the forecasting and the detection of tornadoes, so that 10 years ago the average lead time for a tornado warning was a negative 8 minutes, meaning that a tornado would have been on the ground 8 minutes before someone would have observed it and reported it, and a warning would have been gotten out. Today, the average lead time for a tornado warning is a positive 12 minutes, and I believe that that will go to 20 and 25 minutes very soon.
Generally, we do very, very well now in forecasting out to about 6 days in weather forecasting. We can forecast over relatively small areas. We can forecast the weather in Denver versus the weather in Kansas City 4 or 5 days in advance, and we can differentiate between those two.
The real advances in weather forecasting come from computer modeling. Computer models calculate the weather at certain discrete locations. They used to be about 50 miles apart. Today we use models that have accuracies, and these discrete points are only 10 miles apart. And so they see the Rocky Mountains, they see the Great Salt Lake, they know features there that are on the ground. We can run these models so much faster on the faster computers. They need a lot of data to be accurate, and we're getting new data from new satellites that are being launched. I think the data from satellites is very, very impressive.
Some of the most important research work currently being done in the field of meteorology involves hurricanes.
We're in fact conducting research to better understand hurricanes and how hurricanes interact with the ocean. Numerical forecast models, which tracks the hurricanes reasonably well, don't do such a good job of predicting the strengths of the hurricanes and the rapid changes in strengths of the hurricane. So what we do is we develop new sensors, new technology, bring them to sea and take measurements, bring that data back and analyze it to provide new insight. What's unique about the hurricane program is that you obviously don't want to be at sea doing measurements within a hurricane if you can help it. So in fact we're developing autonomous instrument packages that can be placed out of airplanes where we'll be flying through hurricanes, dropping these into the hurricane itself, and then allow these sensors to bring, in fact, talk by satellites back to us. So after they're deployed, they'll stay in the ocean for a number of months, and we'll measure the various hurricanes that pass over them and understand the ocean physics, hopefully better based on the information we get out of the sensor packages.
Clearly, the progress being made in meteorological research is impressive, but there remains a great deal of work yet to be done.
I'd say there are 3 major challenges facing us in the future. And the first one is to decide if we thoroughly understand the building blocks of climate. And by that I mean, are there certain features that we've neglected to look at? The second thing is with global warming, climate change. How is that going to be manifested? I don't think we know that.
The real issue is that by changing the heat dynamics of the atmosphere, you're going to change all kinds of other things, patterns of weather, patterns of storminess, where it's wet, where it's dry, and those will have regional impacts. The real fear with global warming is not that this average is going to cause a problem. It's really that there are uncertainties in this system.
And the third thing we have going is the impact on population. Our population is growing enormously, in some countries 4 or 5% a year. And that's 17, 18 year doubling timescales. So the reaction of those populations to climate change we don't understand. So what I'm painting a picture of is of a complex system of climate variability, of global warming, of population and human reaction, that is such a complex system that I don't think we can predict the outcome of these. So it's an unpredictable system perhaps.